Hi, and welcome to day 8 of functions. Today we are going to be graphing the inverse functions that we were working with yesterday. So, given the following graphs, find A, the domain and the range of the function, B, graph the inverse, and C, find the domain and the range of the inverse. Okay, for number 1, A. Okay, so A, the domain is equal to, well, this is a line, and if you notice, there's arrows on the end. That means it keeps going forever and ever and ever. It's not just a segment, so it doesn't have stopping and starting points. So therefore, the domain is all real numbers. And the range is the same because it's just a linear function. So that was part A. Part B, graph the inverse. Well, yesterday when we were talking about inverses, we said you just switch x and y. And over here, I wrote out the values, the points, so that it would be easier to graph them. So I'm just going to switch my x and my y values. So it is 4, -1, 2, 0, 0, 1, and -2, 2. So now I need to graph that. So I do 4, -1. And then 2, 0. And then 0, 1. And then -2, 2. Okay. So I'm going to do my best to draw a straight line on the screen here. Okay. And that goes on forever and ever. That is F inverse. And we denote that by the -1 of x. So my domain and my range, because it's the inverse, I switch x and y, my domain and my range switch, so it's still a line. Nothing is changing. So all real numbers for both the domain and the range. Now, I want you to notice, if you remember from last year from geometry, I'm going to draw a line on your graph. Okay, and this is the line y equals x. Now, if I was using the actual ruler and paper, you would notice that if I were to take and fold my paper on the line y equals x, that would be the fold line, the line y equals x, you would notice that these lines are a reflection of each other. When you switch x and y, it's the same thing as reflecting over the line y equals x. Now you did that last year in geometry. Okay, let's try number 2. Number 2, my domain, well, my x value starts at 1 to -3, and it's equal to, because it's all closed circles, less than or equal to x, less than or equal to, it goes over to +1. And my range, that's a 1 there, not a y. The range, my bottom number is 1, 2, 3, 4, -5, less than or equal to y, less than or equal to -2. Okay, this is a segment, not a line. It has definite stopping and starting points because it has points on the end. So that was part A. Part B is to graph it. Again, I wrote the points, the coordinates over on the left-hand side here. So I'm going to use those, and I'm going to switch my x and my y. So it's -2, -3, -3, 0, and -5, 1. Now I need to plot those points. -2, -3, and then -3, 0. And then -5, 1. And I connect my points. Sorry, it's hard on the screen. The best I can. And it kind of looks like a bird flying away. And then to find my domain, remember my domain goes from left to right. My domain starts at 1, 2, 3, 4, -5, less than or equal to x, less than or equal to, it stops at -2. My range, it goes down 1, 2, 3, that's my starting point, less than or equal to y, less than or equal to, it goes up to 1. Now look at part A and part C, you can see that the domain and the range switched. What was the domain became the range. What was the range became the domain. The values are there, but you just change your x and your y. Again, if I use a straight edge, draw the line y equals x. Okay, mine's not perfect. Again, I apologize. You can see that it would be a reflection over the line y equals x. If you have a graph and you draw the line y equals x, if you reflect it over the line, you have an inverse. So if you have a graph and you're checking to see if another graph is the inverse and it doesn't reflect over the line y equals x, then it's not an inverse. Okay? All right, next page. What do you notice about the domain and the range of the original function and the inverse? We just talked about that. They switch. The line y equals x is its own inverse. Therefore, it's called the identity function. Under composition. The line y equals -x is its own inverse. Okay, so what that means, if I take the line y equals x and -2, -1, 0, 1, and 2, just put some points. If this line y equals -x, all the x's are equal to each other, all the y's are equal to each other. If I were to just switch x and y, nothing is going to change. That's why it's the identity function. So the line y equals -x, so this is y equals x, and this is y equals -x. So if I have -2, -1, 0, 1, and 2, that would mean that this would be 2, 1, 0, -1, -2. Again, if I switch x and y, really nothing is going to change. I'm still going to have the point -2, 2 on my graph. It's just going to appear at the bottom of my chart instead of the top of my chart, but that doesn't change the fact that you still plot the points the same way. So that's why it is also its own inverse. All right, this was the last new lesson for functions. Everything else will be review for your tests in a couple of days.